Alright guys, we'll jump into our trig graphing sections, 5.3 and 5.4. Let's start by talking about the general trigonometric function, okay? So there's going to be 4 variables that you're going to see here, I guess 5 if you include the x. Each one of those variables is going to represent something specific about the trig function, which we'll really get into a little bit more in our next part of notes, part 2 of the trig graphing. Alright? The general trigonometric function is a, and then really you can fill in the blank with any trig function you want here. Sine, cosine, tangent, secant, cosecant, cotangent. We'll just use sine as an example of b times the quantity x minus c plus d. Okay? The trig function will always be there. The x will always be there. The a, the b, the c, and the d, those are going to play important roles in properties of this function and also how we graph the function. Okay? So let's define some properties of trig graphs. The amplitude of a trig graph, first of all, amplitude is only defined for continuous wave-like functions, and is defined as the distance vertically from the middle of the wave to the top or bottom. Okay. We will talk more about amplitude with this definition when we actually graph sine and cosine here. Okay? So the amplitude is only defined for wave-like functions, so it's only defined for sine and cosine only. None of the other trig function graphs will have an amplitude at all. We can't even consider it. Okay? Alright, the period of a graph. Now we need to talk here that trig graphs are what we call cyclical. Okay? So trig graphs are cyclical. That means in a certain value of x's, in a certain horizontal distance, if we continue on with this horizontal distance, these graphs will repeat themselves. And that's what it means for a graph to be cyclical. Okay? The period of a graph, of a trig graph, is the distance horizontally for the graph to complete one cycle. Okay. So if you can think about it, and we'll get to this, a sine and a cosine are going to be like a wave. All right? Something like this. All right? From here to here might be one cycle. Because if we keep going, can we see that the graph starts over? This might be the second cycle. Okay? And the period would be this distance, or this amount of x values, if you will. Okay? When we talk about transformations, we'll talk about shifts. The c is going to be our horizontal shift. Any number subtracted or added to the x within parentheses, that would be our horizontal shift. Our d will end up being our vertical shift. We will again talk more about these in the second part of our video. Okay? For today, we're only going to be graphing the parent functions. That's something you should be familiar with from our first chapter and from Algebra 2 Trig. Domain and range, simple things. A trig graph has a domain and a range just like any other function. The domain is all x values, and the range is all of the y values. Okay. And we've talked a little bit about the properties, and now we get into graph the actual trig functions. These are going to be our parent functions here, okay? Just like the square root of x, or x squared with no numbers added or subtracted, with no numbers multiplied in front, okay, are the parent functions for their own function, the square root function, the absolute value function. Sine of x is going to be the parent function for all sine graphs, okay? How are we going to figure out what this parent function looks like? We're going to use values from the unit circle, okay? So we need to think about the sine values and how many rotations, how far from 0 all the way around the unit circle would sine then repeat itself, okay? And you would see that sine repeats itself every 2 pi radians. For that reason, our parent function, we're going to graph one cycle. So we're going to graph from 0 to 2 pi. And we're going to create our table down over here. We're not really going to use this side of the graph. This will be our x, this will be our sine of x. And we're going to use 5 specific x values. And they're going to be all of our quadrantal angles. Okay, quadrantal angles, if we're thinking of this coordinate plane as a unit circle, which eventually it's just going to turn into an xy plane. At 0, at pi over 2, at pi, at 3 pi over 2, and at 2 pi, we want to know the values of sine of x. We're going to ask you to graph 5 points each time, 5 x values, equally spaced. 0 to 2 pi, halfway in between that is pi, halfway in between 0 and pi is pi over 2, the average of pi and 2 pi is 3 pi over 2. Each one of these are spaced appropriately. It's basically a quarter of the period. Okay. If we were to look back at our unit circle, at 0 radians, sine, remember that's the y value, would be 0. At pi over 2, sine is 1. At pi, sine is 0 again. At 3 pi over 2, sine is negative 1, back to 2 pi, where sine is 0 again. Okay. So how are we going to graph this? Well, our x values are going to be our angles from the unit circle. 0 all the way to 2 pi. Halfway in between that is pi. The average of those two, pi over 2. 3 pi over 2. Our y values for sine, the parent function, will go from negative 1 to 1. And let's just graph our points and see what this looks like. Here's 0, 0. Here's pi over 2, comma 1. Here's pi, comma 0. Here's 3 pi over 2, negative 1. And here's 2 pi. And as you notice, we are going to get something that looks like a wave. This is the graph of sine of x. Notice we have 5 x values. We have 3 y values. We have a middle of the wave. We have a top of the wave. We have a bottom of the wave. Okay? So let's talk about the specific properties of this graph. The amplitude of the parent function sine graph, remember, is defined as the distance vertically from the middle of the wave to either the top or bottom. From the middle of the wave to the top or bottom, the amplitude is 1. The period is defined as the horizontal distance of one cycle. How long it would take this graph to then start repeating. That would be 2 pi. Okay. Now we have to remember that even though we're graphing one cycle, this graph will continue on forever. It will keep making its wave all the way to infinity and negative infinity, making the domain all real numbers. It will never go any higher than 1 or lower than negative 1, however, making the range negative 1 to 1. Okay? That's our sine graph. We're going to do the same thing here for the cosine graph. Let's make our table of cosine values. This comes straight off of your unit circle. We're going to use the same x values because cosine will also take 2 pi to make one cycle. 0, pi over 2, pi, 3 pi over 2, 2 pi. At 0 degrees or radians, cosine is actually 1. At pi over 2, 0. At pi, -1. At 3 pi over 2, 0. At 2 pi back to 1. Let's graph it. 0 radians, 2 pi radians. Halfway in between that, pi. Pi over 2, 3 pi over 2. 1, -1. At 0, cosine is 1. At pi over 2, 0. At pi, -1. At 3 pi over 2, 0. At 2 pi, 1. Again, if you're curious about how we got those values, it comes straight from our knowledge of the unit circle. All right. As you can tell, the amplitude is 1. Here's the middle of the wave. Even though we don't start there, we start up here, but we start at the top. Middle, bottom, middle, top. The period, just like sine, it would take 2 pi to have it repeat. The domain would be all real numbers. The range, -1 to 1. We'll get plenty of practice with this. Just want to show you where all this comes from. Okay. The one difference with tangent of x is that it takes only a distance of pi to repeat itself. Its period is pi. Okay? It does not have an amplitude. Okay? And for tangent, the x values that we want to use for it to complete one cycle, we're going to be going from -pi over 2 to pi over 2. We're going to equally space the rest of the x coordinates. Okay. Now straight off your unit circle, tangent is sine over cosine, remember. All right. As you can see, cosine is 0 at pi over 2. I'll show you the graph. If cosine is 0 at pi over 2, and tangent is sine over cosine, then at pi over 2, tangent is undefined. It's also undefined at -pi over 2. At the pi over 4s, remember sine is root 2 over 2, cosine is root 2 over 2. Okay, so tangent would be -1 here and +1 there. At 0, sine is 0, cosine is 1, 0 divided by 1 is 0. All straight from our knowledge of the unit circle. Okay, so we'll go -pi over 2, -pi over 4, 0, pi over 4, pi over 2. At undefined spots on a graph, let's think of our knowledge of graphing, we would actually have a vertical asymptote there. And then we'll plot our points at -pi over 4, -1, 0, 0, pi over 4, 1, and this is the graph of tangent. Okay. Its period is pi. That's the difference, one of the differences between sine, cosine, and tangent. The parent function period is pi. The range, -infinity to infinity, as you can see these arrows from bottom to top. The domain of this graph, okay, we have to exclude these asymptotes. But since this is cyclical, the asymptotes will continue to happen every distance of pi. So here's how we write that. All real numbers where x cannot equal -pi over 2 plus pi k, where k is an integer. Okay. We'll talk a lot more in class about the domain of functions that have asymptotes but repeat themselves. This is basically one of the asymptotes for any integer You come to the x value, you'll find an asymptote.